Okay, go Giants. One win down, 3 to go. Guys, prime factorization. The main idea, let's see what I wrote here for the main idea. It says when two numbers are multiplied, they're called factors, those two numbers that are being multiplied. They're factors of the thing that you get, okay, the product. A number can be written as a product of primes, okay? I like to call this a number's recipe. It's what makes up the big number, right? When we take a number and we break it down to its prime factorization, using prime factorization, those things are the ingredients that make up the big number, okay? The prime factorization of the number is like a list of ingredients. A prime number is a number that has only itself and 1 as factors. So some prime numbers are 2. It's the only prime number that's even, because every other even number, 2 goes into it. All right. So 2 is the only even prime number. 3 is prime. 5 is prime. 7 is prime. Is 9 prime? No, because 3 goes into it, right? How about 11? 11 is prime. 13? Yep, 13 is prime. 14? No, it's even. 2 goes into it. 7. How about 51? 3 goes into it, right? Yeah, exactly. 3 times 17. All right. It kind of tricks us. You think 51, you're like, man, my multiplication tables, I never get 51. But 3 times 17 is 51. How about 41? How about 41? Is that prime? Yeah, 41's prime. Okay. Now, a composite number is a number that has factors other than itself and 1. Okay. Is 1 a prime number? No, it's not. And the reason it's not is because it doesn't have two distinct factors. The only thing that goes into 1 is 1. Okay? And to be a prime, you have to have two distinct factors, 1 and itself, something other than 1. That's why 2 is prime. Yeah, Zachary.
You just told us one of the answers.
Oh, did I? Man, I just told you one of the answers. That's all right. I'm nice that way. Guys, one other thing here. A monomial is another name for an expression that has just one term. Okay? So something like 4x, that's a monomial. But this, 4x plus 2, this is called a binomial because it has two terms in it. Okay? But this thing is called a monomial. All right? Okay. Now, let's let that stuff go to the side. And let's talk about this first problem. It says you're working on your school yearbook. Each page will have 24 student photos. All right. The photos will be arranged in a rectangular display with the same number of photos in each row. Okay. How many ways can you arrange the numbers so that there are no more than 10 photos in any row or column? Okay. So we know we've got a page of pictures, right? And we know we have to have the same number in every row or column. What could it possibly be? How could we break them down, or how do we do that, Zachary?
You turn 24 or you divide 24 up into
You list its factors. You list its factors. 1 and 24, but that doesn't work because it said no more than 10 in any row or column. How about 2 and 12? No, that's too high. Right? But we could do 2 rows of 12 or 2 columns of 12, right? But they said no more than 10, so that doesn't work. What else goes into it? 3 and 8. That one works. Good job, Hobbs. All right, that one works. Anything else, Cole? 4 and 6. Good, that one works, right? Because none of them are more than 10. Anything else? 8 and 3, but that's just the same thing, isn't it? Okay. All right, so these are our two possible combinations that would work for us. Excellent job, guys. That was just a way of thinking about factors. These are the list of the factors of 24. Okay? All right. Great job, guys. Let's look at example number 2 then. Okay?